Pause the video now, guys, and try, okay, this 7-mark question. So question 9, which is a 5-marker, and question 3, which is a 2-marker, from the Edexcel Full A-Level Maths Pearson, okay, GCE, okay, and it's from a paper to paper, and these questions are likely to come up on tomorrow's exam. Okay, so pause it, try it, and then press play. Okay, question 9. Given that a is a constant and so the definite integral between 1 and 4 of 3 root x plus a dx equals 2a squared, so that there are exactly 2 possible values of a. So step 1, write it in index form. So we got the integral between 1 and 4 of 3x to the power of a half plus a dx. Okay, so integrate that here using the rules of integration, okay, which is given to you in the formula book, I think. You add 1 to the power and you divide by the new power, okay? Remember, that does not apply for when you have the integral of 1 over x, okay? That obviously becomes natural log x, okay? But for any other power of x, you add 1 to the power and then you divide by the new power. So we're going to have 3x to the power of 3 halves. We're dividing by 3 halves, so we're going to multiply by the reciprocal, so we're going to multiply by 2/3. So the 3's here are actually going to cancel, okay? So I'm going to have 2x to the power of 3 halves plus ax, okay? That's between the limits of 4 and 1. I'm now going to substitute in x is 4, okay? Subtract the x limit of 1. So we're going to have 2 lots of 4 to the power of 3 halves, okay, plus 2a, okay, put that in brackets, subtract 2 lots of 1 to 3 halves. Well, that would be just 2, okay, because 1 to 3 halves is just 1, and then you've got to have plus 1a, okay. So this summation is equal to 2a squared, okay. So let's just obviously simplify the bit inside the bracket and obviously collect like terms, okay. So 4 to the 3 halves, that's the square root of 4, which is 2, and then you cube it, I get 8. So you have 16, okay, minus 2, so that'll be 14. Then you've got 2a minus 1a, okay, or minus positive a. So 2a minus 1a will be plus a. So 14 plus a is equal to 2a squared. Okay, I've now got a quadratic that I can rearrange it to make equal to 0. So I'm going to subtract 8, subtract 14. So I'm going to have 2a squared, guys, minus a minus 14 is equal to 0. Okay, factorize the using using your calculator or use the formula. Okay, either way is going to be fine. Okay, I'm going to try and see factorize it and do the trial and error method. So we're going to have 2a, okay, and then a. So we want 2 numbers that add to make minus 1 and times to make minus 14, and then obviously one of them is being doubled. Okay, so I'm going to have 2 and 7. Okay, so what will that be? Um, you got 14, so you got 2 and 7 and 1 and 14. Okay. 2 and 7. Okay, so we want to make minus 1a. No, sorry, guys. It should be minus 3a. Sorry. Is 2a minus. No, sorry. No, I'm actually sorry. Ignore me. Wait, 4 to the 3 halves. So that's going to be a square root of 4, which is 2. Cube it, I'm going to get 8. Okay. Then I'm going to have 2 times 1 to the 3 halves. So that should be 2 plus 1a. Yeah. So that'll be 16 minus 2, which is 14. Okay. I think my mind just gone blank. Sorry, give me 1 second, guys. So two numbers that add to make minus 1 and times to make 14. It can't be 7 there because that obviously make it minus 14. Why is my mind gone blank now? Sorry, guys. Give me just 1 second here whilst I'll give it just a go again. 2a. No. I did this literally today on paper, but for some reason I put I put 2a instead of 4a. Okay, there we go. Right, there we go. I knew I made a mistake. So it should be plus 3a. Okay, there we go. I've now fixed it. Okay, I put in the wrong value of x, sorry, for my upper limit. Okay, I put in x is 2 rather than x is 4. Okay, I can now factorize this. Okay, 2a minus 7. No, sorry, 2a plus 7, sorry. And then a minus 2. Okay, check it, and sure. So a equals minus 3 halves or a equals minus 2. Okay, there we go. Okay, phew. Okay, so that, guys, is my answer for part A. Okay, sorry, yeah, for obviously making a little actually mistake there. I apologize again. Okay, I copied that actually the wrong number there. Okay, so again, obviously always check your limits. Okay, that's part A. Sorry, question 9 actually done. What about question 3? Well, relative to a fixed origin, the position A has the vector 2i plus 5j minus 6k, and point B has a position vector 3i minus 3j minus 4k. Point C had position vector 2i minus 16j plus 4k. Find vector AB. So vector AB is B minus A. So it's vector B minus A. So you collect all your I components, collect all your j components, and collect all your k components. So you're going to have 3i minus 2i, that'll be 1i, or just I, minus 3j minus 5j, that'll be minus 8j, and then minus 4k subtract negative 6k is minus 4k plus 6k, so that'll be plus 2k at the end, and that was worth 2 marks. Okay, and that was a part A of a question. Okay, so again, these are 2 questions that are likely to come up in tomorrow's exam. Okay, so spend maybe tomorrow morning going over vectors and some integration. Okay, sorry guys, my cursor is just frozen. I apologize. Okay, there we go. Okay, right guys, that's it for me today, guys. Okay, thanks for watching. Take care. All the best. Okay, good luck for tomorrow. Bye for now.